Let's take a look at this section, solving rational equations. And here's the general procedure for this. So what we're going to do here is we're going to go through every single step using problem number 63, this one right here. And then we'll see some ways we can shortcut this a little bit. But the shortcut will make sense as long as we understand the general idea here. So let's start. So the first thing we're going to do is we're going to factor each denominator so that we can get the LCD. So we're going to rewrite this as 2x over, and we've got the difference of 2 squares, so let's write our 2 parentheses, anticipating we can factor. So we'll get these conjugates, x plus 3, x minus 3, equals 2 over, and what do you know, these two denominators just happen to match our first one. Now, here's the LCD. The LCD is, we're going to have x plus 3, x minus 3. Make sure you agree. You know, we've got x plus 3 appears here, but it's just to the first power, so we just need to use it once. That x minus 3 appears here, it appears here, but it's just to the first power, so we just need to use it once. So here's our LCD. I'm going to circle that so I can find it later if I need it. Now, here's what we're going to do. We're going to multiply both sides of the equation by the same non-zero number. So we have to be sure that this is not 0. And the only way this is going to be not 0 is, let's make clear here, x cannot be negative 3, nor can it be positive 3. If x is either one of these two numbers, this is going to be 0. And we don't divide by 0. And we don't multiply both sides of an equation by 0. So, assuming that the LCD is not 0, let's multiply this side and this side both by the LCD. It's going to look like this. We'll have our LCD x plus 3, x minus 3 times the left side 2x over x plus 3, x minus 3 equals, and now the right side, this is going to be x plus 3, our LCD, x minus 3 times that entire right side. Maybe I'll just do this. 2 over x plus 3 minus 1 over x minus 3. I'll use these brackets just to indicate that I want our LCD times the whole right side. Now, since I'm looking for a general approach here, I'm not going to cancel these denominators just yet. I'm going to go ahead and multiply. I'm going to distribute through here. So we'll rewrite what we've got here. Just rewrote that here. And now over here on this side, I'm going to distribute this LCD to this term and then to this term. So this gets a little bit long, as you can see. So we're going to have our LCD, the x plus 3, x minus 3 times that first term, 2 over x plus 3, minus the LCD again, x plus 3, x minus 3 times that second term, 1 over x minus 3. So let's be sure we've got it here. I've got the LCD times the left side equals, now here's the LCD times the entire right side, and then I distribute, right? So I get this times this, there it is right there, minus this times this, and there it is right there. So here's what we really want to see. You see that LCD that we got? So what we did is we started with this equation, we factored the denominators, we got the LCD. Then we multiplied both sides by the LCD. But where does that LCD end up? It ends up right next to all of the originals, right? The LCD is right, I'll go back to the very original, well, almost. The LCD ends up here, here, and here. Once we distribute, I got the LCD in front of the leftmost term, the LCD in front of that middle term, and the LCD in front of that right term. So this is what we're going to do from now on. We're really going to try to skip this step here, because we know what's going to happen. The LCD will end up alongside every term. Okay, let's continue on. So all I did here is I just rewrote our last equation here. I just wrote it up on top a little bit smaller so I can squeeze it all in. And now, if we continue, what we're going to get here is that you can see on the left side here, right on this side, this x plus 3 minus 3 will cancel with this x plus 3x minus 3, so we can cancel those. And if we do that, we're just left with this 1 times 2x. And 1 times 2x is just 2x equals. So on this right side, what you can see here is that this x plus 3 here is going to cancel with that one, and that will leave us with this 2 times the x minus 3. So let's write that one. We'll get 2 times that x minus 3. Now on this right side over here, you can see this. This x plus 3 is going to cancel with that one. So let's actually do that. Let's cancel that x plus 3 with that x plus 3, and doing so leaves us this 2 times x minus 3. So let's write what we have. On the left side, we have this 2x, and on the right side, we're going to have 2 times x minus 3, then this minus sign, and then you can see that this x minus 3 is going to cancel with this one, leaving us with 1 times x plus 3. So we can write that. We'll get a 1 times x plus 3. Now, let's continue on. We're going to get 2x equals, now, let's distribute here. We'll get 2x minus 6, so that'll give us 2x minus 6, and then, let's distribute here. Negative 1 times x is minus x, and negative 1, that negative 1 times positive 3 is going to be negative 3. We can fix up the right side a little bit. We're going to get 2x equals, now we've got 2x minus x. That'll leave us with an x. And then we've got negative 6 minus 3 gives us a minus 9. Now here's a nice linear equation. We've got x's on both sides. Let's subtract x from each side to get all the x's on the left. That will give us x equals negative 9. Now that looks like a solution, but we need to be careful. Let's run a check here. We're thinking x is negative 9, but let's look all the way back over here to our LCD and excluded values. Remember, we had to, this whole thing works as long as x is not equal to negative 3 and 3. Because if it is, up here we're dividing by 0, and then we're multiplying both sides of an equation by 0, which we don't do. So we've got negative 9. The excluded values are 3 and negative 3. We have neither one of those. So now we are going to conclude that, sure enough, x is equal to negative 9. Okay, so let's just say what it is we're going to do here. Here's the general procedure. We're going to start with some equation involving rational expressions. We're going to factor those denominators. We're going to get the LCD, look for excluded values. Then essentially what we're going to do is, let's skip this step here. We are going to write that LCD in front of every one of the original terms, as we did up here at the very top. And then you can see that all the denominators factor, and you're just left with a nice linear equation which you can solve. You get a solution and just run back and check to see that it's not one of those excluded values. And that should be it.